Assignment 27, 4.3, derivative of a quotient of two functions. So now we're going to talk about what happens when you have two functions being divided. How do you find the derivative of that? Your essential question: how to use the quotient rule. To find the derivative of the quotient of two functions. So on your last test, a lot of you guys had to take the double derivative. I forget what it was. It was the ln of something. And I think you ended up with something that looked like this, and you had to actually take the derivative of this. So I'm going to take the derivative of this with respect to x. Okay, so what a lot of you guys did was you ended up saying, well, this is the same thing as 7 times x to the negative 1 power. And then you were able to take the derivative of this, which ended up giving you negative 7x to the negative 2. Or in other words, negative 7 over x squared. Okay, so that's not always going to be feasible. You're going to actually need to know the quotient rule. You're going to need to know how to do this if it was something other than like x in the denominator. Okay? So that is why we have this thing called the quotient rule. And just like the product rule, you need to memorize it. And basically it says that if y equals u divided by v, then y prime will equal, or the derivative of y will equal, the derivative of u times v minus u times the derivative of v all over v squared. Okay, so just like the product rule, I'm going to write this in quotations so that you have something that you can always say to yourself, okay? So the quotient rule is you take the derivative of the top times the bottom minus the top times the derivative of the bottom all divided by the bottom squared. Oops, sorry. So again, for the quotient rule, say this to yourself a million times. Say it before you go to bed, like maybe 100 times a night. And same thing with the product rule. Okay, if you do that, if you get this down, these are going to be really easy. Okay? All right, so let's try some problems from your book. Okay, so I'm going to try number 2 from this section. So you have f of x equals x to the 4th power over cosine of x. And I have to figure out the derivative of this. So this is going to be f prime of x. Okay, so I'm going to take the derivative of the top times the bottom. So the derivative of the top will be 4x cubed times just the bottom, which is cosine x. From that, I'm going to minus the top times the derivative of the bottom. So I'm going to minus the top, which is x to the 4th, times the derivative of the bottom, which will be negative sine x, all over the bottom squared, which is cosine x, the whole thing squared. Okay, so if I wanted to simplify this, this would really be 4x cubed cosine of x plus x to the fourth sine of x all over cosine x squared. Now, if it would do me any good, in other words, if I could do maybe some reducing, so if there was a common factor up here and down here, I might want to factor out that greatest common factor and do some reducing. I may also be able to rewrite these. So for example, if I was able to factor out like a sine x squared, then I could say, okay, well, this is a tangent squared now, but that's not happening here. So we are done. Let's do some more problems. How about number 8? So number 8 has y equals 10x plus 9 all over 5x minus 3. Okay, so I'm going to now take the derivative of y with respect to x. So I do the derivative of the top. So the derivative of the top is just 10 times the bottom, which is 5x minus 3, minus the top, which is 10x plus 9, times the derivative of the bottom, which just happens to be 5. Okay, now this is going to be a little bit tricky. You're going to need to realize that this 5 gets multiplied to this whole thing. Okay? All over the bottom squared. All right, let's see if there's anything that we can do here. Let's do some simplifying. So I'm going to have 50x minus 30. Okay, now this is going to get a little bit tricky. So this is really like a negative and a 5 that are being distributed, okay? So I'm going to have negative 50x minus 45 all over 5x minus 3 squared. Well, I have a 50x minus a 50x, so the x's go away. So I'm really just left with negative 75 over 5x minus 3 squared. Again, if I had thought maybe there would be some common factors, I might want to either maybe, well, I can't see why I'd multiply this out, but maybe if this, if there was something to factor up here and maybe I could reduce, or maybe if it was this plus something and I had some other quadratic up here, I might want to multiply it out, factor it again, and see if I could reduce with any common factors. But I think we're good here. All right, so let's do one more. We'll make it a little bit more challenging. What if I give you a equals, and this is number 10 out of your book, 4x minus 1 to the 7th power over 7x plus 2 to the 4th power. Okay, so this will I'll just say, how about a prime? Derivative of the top. Okay, so I'm going to start by doing the outside. Oops. Times the derivative of the inside, which is 4. Okay. Times the bottom, which is 7x plus 2 to the 4th. Minus the top, which is 4x minus 1 to the 7. Now this is going to get a little bit tricky, so I am going to put this minus in brackets, everything I'm doing from here on out, because I just don't want to end up maybe not distributing my negative to everything. And if I'm going to have a whole bunch of terms, you just never know. So I'm just being really cautious right now. All right, so now I need to do the bottom. So that's going to be times 4, 7x plus 2 to the 3rd, times the derivative of the inside, which is 7. So it looked like I didn't really need that, but I was just being cautious. All over the denominator, or the bottom, squared. Okay, so continuing on from here, let's see what I've got. Well, it looks like I have a 28. And then a 4x minus 1 to the 6th. And a 7x plus 2 to the 4th. Now over here it looks like I've got minus another 28. And maybe a 4x minus 1 to the 7th. And a 7x plus 2 to the 3rd. And all of that is over 7x plus 2 to the 8th power. So I see some common factors, and I also think that I could probably reduce some of these 7x plus 2's. So I am going to continue factoring. And I'm just going to go ahead and do as much factoring as possible. We'll see what ends up reducing, okay? I see that on the top, my greatest common factor is 28, so I'm going to pull that out. I also see that they have 6 4x minus 1's in common. And they have 3 7x plus 2's. So what's left then is a 7x plus 2 for the first term. And in the second term, I think we have a 4x minus 1 left. All of that over 7x plus 2 to the 8th. Okay, well right away I can see, oh, these are going to reduce. This one's going to go away completely. And here I'm just going to have 5 left. So I'll end up with 28, 4x minus 1 to the 6th. Here inside these brackets, I'm actually going to have, I'll just write those with parentheses now, 7x minus 4x, which is actually 3x, and then 2 plus 1, which is 3, all over 7x plus 2 to the 5th power. No more reducing can be done. However, I can do a bit more simplifying. So my last step here is going to be the fact that I don't want to multiply this all out. So I'm just going to leave that. But I can definitely take this 28 and multiply it by 3x and 3. So 28 times 3 is 84. So I'm going to have 84x, plus 84. And then that's going to end up getting multiplied to 4x minus 1 to the 6th power, all over 7x plus 2 to the 5th. And this can be simplified just a little bit more, just to take this one step further, just in case sometimes in the back of your book things can look a little bit crazy. So if we take 84 out of here, we'll be left with x plus 1, 4x minus 1 to the 6th, all over 7x plus 2 to the 5th power. So at this point, any of these 3 answers would be fine. It just really depends on if you're trying to check your answer and see that you got it right. The book doesn't have this answer. It actually has this answer. Okay, so I just kind of wanted to show you all the different ways that you can go. Even though, in my opinion, at this point, there's not much use in factoring this out because you're not going to be able to reduce anyways.